Today we will be discussing about the first chapter, that is the real number. So in the last class I have discussed the different types of numbers in our number system. So today we will be discussing the first topic, that is the Euclid's division lemma. Now before going into the lemma or before going into this topic, first of all we'll be discussing the definition of lemma. Now what is a lemma? You see, a lemma is a proven statement. You may note this down. Lemma is a proven statement which is used to prove other statements. Okay, so a lemma is a proven statement which is used to prove other statement. Now another term that we will be using in this chapter is algorithm. Now most of you might have came through this word algorithm. Now what is algorithm? Now this algorithm, okay. Now this algorithm means the procedure, or you can say a series of well-defined steps used to solve a problem. Is it clear? Now we have discussed the basic terms, or these terms will be used in this chapter. One is lemma and the other one is algorithm. Lemma means a proven statement which is used to prove other statements, and algorithm is a series of well-defined steps, or we can say the procedure used to solve a problem. Okay, so we'll be discussing using these words in the chapter, throughout the chapter. Fine. Now we'll be going into the Euclid's division lemma. Okay. Now what is Euclid's division lemma? So this is the first theorem that we will be getting in this chapter. Theorem 1. Okay. Now the first theorem is the Euclid's division lemma theorem, or you can just write Euclid's division lemma. Okay. Now what is this Euclid's division lemma? The statement is, for any two given positive integers, okay, for any two given positive integers. Now you just focus on these positive integers. Now you remember what is integer, okay, and this integer must be positive. Now for any two given positive integers, what are the given positive integers? Let it be a and b. Okay. Now for any two given positive integers a and b, there exist, okay, there exist unique whole numbers q and r such that A equal to BQ plus R. Okay, I'll explain what does it mean. Where R equal, or you can say where R must be greater than or equal to 0 or less than B. Okay, R must be greater than or equal to 0. That means it may be 0 or it may be equal to, it may be 0 or it can be greater than 0, but it must be less than B. Is it clear? So this is the statement or the mathematical statement of the Euclid's division lemma. So now what does this mean? Okay, it's very simple. It's very simple. Now by looking at the statement, it seems like it will be quite mathematical, but nothing is like that. You have used this thing from your very basic classes like class 3-4. You have used it in class 3-4 like that. So now what is this lemma means? You see what it defines. You see, let us consider any two positive number. Suppose one is 13 and other number be 5. Suppose. Okay. Now these two, 13 and 5, are what? They are positive integers. Okay. Now you have to write this in the form A equal to BQ plus R. So how we can write this in the form A equal to BQ plus R? Now consider this 13 to be equal to A and this 5 to be equal to B. Or you can say A equal to 13, B equal to 5. Now you divide 13 by 5. Now when we divide 13 by 5, what you get? You get 2 as the quotient, 5 2s are 10, and the remainder is what? 3. Now you see, when I'll have to write this, you can also write it like 13 equal 2 into 5, or you can write 5 into 2 plus 3. That's very basic. 5 into 2 how much? 10. 10 plus 3 it is 13. So you can also express 13 in this form. Okay. Now this is what the Euclid's division lemma says. If you have any two positive integers, you can write it in the form A equal to BQ plus R, where the R is the remainder, that is R can be equal to 0, remainder can be equal to 0, or it can be greater than 0, but it cannot be equal to the term B. Here it is mentioned as B, but in general B is the divisor. That we will be discussing later. Okay, now you see I have written this 13 as 5 into 2 plus 3. So if you consider A is 13, then this will be the what? This A will be what? Wait. This A will be, the dividend, correct? B is the divisor, correct? Q is the quotient and R is the remainder. Is that clear? So now we will be using this basic theorem to find out the HCF. Okay, we will be using this to find out the HCF. Now what is HCF? HCF is the highest common factor. Okay, if you'll be given two numbers, and from that two numbers you have to, among that two numbers you have to find out the highest common factor. That we will be doing in the chapter. Is it clear? Now before doing that, we will be discussing an algorithm. Now what is algorithm? As I have discussed earlier, just before some time, algorithm are some steps or well-defined steps used to solve a problem. Is it clear? So students, this is clear to you? Okay, you may write, if you have any doubt, you may write it in the comment box. Now we'll be going to the to the algorithm that is the Euclid's division algorithm. Now we will not be discussing the lemma anymore. We will be discussing the algorithm. That means the steps that are involved in solving problems. Is it clear? Okay. So now we have the Euclid's division algorithm. Okay. Now what is Euclid's division algorithm? Okay. Now you see, this Euclid's division algorithm is used to obtain the HCF of two positive integers. Okay, it is used to obtain the HCF of two positive integers, say A and B. Okay, where or with A must be greater than B. Okay, so now we'll be discussing the steps that are involved in finding out the highest common factor of two given integers or two given positive integers A and B. Okay, so the first step, or the step 1 that is used to find out the HCF is, now we have to apply, first of all we have to apply the Euclid's division lemma that we have discussed, the last of Euclid's division lemma. Okay, you have to apply the Euclid's division lemma. Where we have to apply the Euclid's division lemma? To A and B. Okay, and we'll be finding out, or we'll be obtaining two whole numbers Q and R. Correct? On applying the Euclid's division lemma to A and B, what we will be finding? We will be finding two whole numbers. One is Q and the other one is R. Okay? To find, applying the Euclid's division lemma, A and B, to find whole numbers Q and R, that is the quotient and the remainder, okay, such that A equal to BQ plus R. Okay, the statement that we have just written before. R must be greater than or equal to what? 0, and it must be less than B. Okay, so it's very easy. First of all, what we have to do, we have to apply the Euclid's division lemma to the given positive integers A and B. Suppose you are given two positive integers, one is 135 and the other one is suppose 280. So first of all, what we have to do, you have to apply Euclid's division lemma to 135 and 280, and then you will be obtaining the quotient and the remainder accordingly. Is it clear? Now the second step, it is a very important step that you must note. The second step is that the remainder that you have obtained, okay, the remainder that you have obtained, if this remainder is equal to 0, okay, if R is equal to 0, then B, that means this term B will be the HCF of A and B. Have you understood? Now if R equal to 0, B is the HCF of A and B. So the condition is that R can be equal to 0 or it can be less than B. That means it may be equal to 0, but it may not be equal to 0. Now what will happen if R is not equal to 0? So if R is not equal to 0, then we have to apply the division algorithm, lemma. If R is not equal to 0, we apply the EDL, that means the Euclid's division lemma, to what? Now what we'll be doing is that once I have this at the very beginning, I have in the first step I'll be dividing A with B, then accordingly we will be getting Q and R as the remainder. Q as quotient and R as the remainder. Is it clear? After that, if R is equal to 0, then B is the HCF. Here it is done. But if R is not equal to 0, then what you have to do is that you have to shift this B to the position of A. That means now we will be dividing B. That means the B will be the dividend now. And it will be divided by the remainder that we got. Is that clear? That means if R is not equal to 0, we apply the EDL or the Euclid's division lemma to what? To B and R. Is it clear? It will be very easy. We will be using some examples to solve this. Okay, you don't need to worry about that. Now, the third step or the third step of the algorithm is the third step will be you have to continue the process. Okay, you have to continue this process. If you have applied the EDL to B and R and again you didn't get the remainder as 0, then again you have to apply the EDL. Okay, now the step 3 is that you have to continue. You have to continue this step. Okay, to continue this step, or you can say this process, till the remainder is 0. Okay, till the remainder is 0, then the divisor, once the remainder becomes 0, okay, then the divisor, okay, once the remainder becomes 0, then the divisor at that stage okay, the divisor at this stage will be what? Will be the required HCF. Have you understood? So these are the steps involved in finding out the HCF of two positive integers. Okay, using what? Euclid's division lemma. Is that clear? So these things we have discussed the theory of this first topic. Okay, now we'll be going into some examples. Okay, so we'll be doing some examples now. Fine. Okay. So let us take two numbers, and we have to find out the HCF of those two numbers. Okay. Fine. So, for example, you take 135 and 225. Is it clear? So, you are given two positive integers and you have to find out the HCF among these two numbers. Okay. So, in your exam, the questions will be of this type. Find out the HCF of 135 and 225, or you will be given some other numbers and you have to find out the HCF accordingly using Euclid's division algorithm or division lemma. Okay. So now in this process, at first you have to identify which is the greater number. So it's very easy. Among 135 and 225, which is the greater number? Obviously 225 is the greater number. So you consider 225 to be A, as in the theorem we have discussed. So at the very first step, what we have to do here, 225 is greater than 135. Okay, so it's very simple. 225 is greater than 135. Okay, now first of all we will be doing the division process. Okay, wait, we have 225. Now this is the dividend as we have discussed. Then you have 135 as the divisor. Good. Then when you divide 225 by 135, what you get? 135 ones are 135. 135. Okay? Fine. Now what is the remainder that you have? You have 0, 22, 13, 9. Okay? So you have 90 as the remainder. Now is 90 equal to 0? No, 90 is not equal to 0. Now since 90 is not equal to 0, what you have to do? You have to take this as the divisor now, and this 135 will be shifted to this place. Have you understood? So we'll be having 135 here now. Now how many times this 90 will be 135? You have 91s are 90. What is the remainder you have? You have 45 as remainder. Okay? Again we have found that the remainder is not equal to 0. Now since the remainder is again not equal to 0, so what you will be doing? So we will be using this 45 as the divisor now. And what will be the dividend? This 90 will be the dividend now. Is it clear? So 45, 2s are 90, the remainder is how much? 0. And since the remainder is 0, we are successful. And what is the HCF now? This 45 will be the HCF. Have you understood? So in this way, we will be finding out the HCF of given two positive integers. Is it clear? So in this way, we will be finding out the HCF of given two positive integers using the Euclid's division lemma. Is it clear? So this is what you have to do in the rough work part. You can do it or you may not do it. But while writing on the exam, or when you will be writing on your exam, you may not use this. You may use it in some other way. I will be showing it now. Here 225 is greater than 135. So using Euclid's division lemma, okay, 225 can be written as 135 into 1 plus what? Plus 90. Correct? Now since 90 is not equal to 0, okay, since 90 is not equal to 0, so what we have done now? We chose, okay, I can write, we have considered, okay, 135 as the dividend, okay, and 90 as the what? Divisor. Correct? So when we have chosen 135 as the dividend, what we got? 135 equal 19 to 1 plus 45. Correct? Again, the remainder is not equal to 0. So what we have to do? We have to apply the process again. That means the Euclid's division lemma again. So once you note this, I'll rub it. Fine. Okay. So now, since the remainder is not equal to 0, what we will be doing now? Since 45 not equal to 0, we have considered, what we have considered? We have considered this to be the dividend, okay, and what? This one is the divisor. Is it clear? Is it clear to you? Okay. As the divisor. Now you see, once I have taken 90 as the dividend, what I will get? 45 into 2 plus 0. Now we got remainder as the 0. And we have discussed in the Euclid's division algorithm, once the remainder is 0, the divisor will be the HCF of the given numbers. So here the divisor is what? 45. Now you can write here the remainder is found to be equal to 0. So 45 is the HCF of 135 and 225. Is it clear?